So now let's use bond energies to calculate the change in energy for a chemical reaction. The basic relationship that enables us to do this is the idea that the change in energy of the reaction can be calculated from the sum, this is a big Greek letter sigma, the sum of the bond energies of the reactants minus the sum of the bond energies of all the products. So basically, what this equation is telling us is that we have to add up all of the energies for the bonds that are broken and then subtract from that the sum of all the energies of the bonds that are formed. So remember, it requires energy to break bonds, and forming bonds releases energy. So that's why we are subtracting the bonds formed. We're taking those values and putting a negative in front of them, essentially. Let's do an example. Calculate the change in energy for this chemical reaction. I2 plus Cl2 gives 2 ICl. So diatomic iodine plus diatomic chlorine give 2 iodine monochlorides in the gas phase. We want to figure out what the delta E for that reaction is given the following bond energies. So bond energies are something that you can look up in the table in chapter 3. And the bond energy for the iodine-iodine bond is 149 kilojoules. For chlorine-chlorine, it's 239 kilojoules. And for the iodine-chlorine bond, it's 208 kilojoules. So you can just look up all these values in the table in chapter 3. So we need to add up the bond energies of all the reactants and then subtract the bond energies of all the products. So that means, well, I should define for you reactants and products because we actually have not defined that yet. Reactants are what are on the left side of the equation. So they are what you begin with, and that is on the left side of the arrow. And the products of a chemical reaction are what you get on the right side of the arrow. So in this particular reaction, the reactants are iodine and chlorine, and the product is ICl. Notice we have 2 ICLs forming. So that means we're going to be taking this bond energy for ICl and we're going to have to multiply it by 2 because we are going to be forming 2 ICl bonds to make 2 molecules of iodine monochloride. So that means when we're calculating the change in energy for this reaction, we should take into account the breaking of the iodine bond, so that's 149 kilojoules, plus the breaking of the chlorine-chlorine bond, that's 239 kilojoules. So those are the bonds that get broken. And from that, we're going to subtract the 2 times 208 kilojoules because we have 208 kilojoules as the bond energy for ICl, and the balanced reaction shows that we have 2 iodine monochlorides forming in this reaction. So the change in energy for this reaction should be minus 14 kilojoules per ICl. So, sorry, I did that math incorrectly. I'm seeing now. Minus 28 kilojoules for this particular reaction. Okay, in the subsequent lecture, we'll do another example.